We're moving right along now with our Mechanics of Materials course part 1 of a 4-part series. Today is module 32. Here's the learning outcome: to develop Mohr's circle for plane strain. And so we left off last time with these plane strain transformation equations for both the normal strain and the shear strain. And so I want you to recall now the stress transformation equations we had for plane stress. So these are the strain transformation equations for plane strain. These are the stress transformation equations that we did for plane stress. And you're going to start seeing similarities between the two. And so you can see that the normal stress corresponds mathematically, same term as the normal strain. Sigma x, sigma y correspond to epsilon x, epsilon y, etc. And so that means when we developed the max and min principal stresses on principal planes, these equations that we developed for plane stress, since these are mathematically analogous equations, we can find the max and min in plane principal strains in principal planes. And we can also find, like we did for the maximum in plane shear stress, the maximum in plane shear strain. So we have a complete analogy here. And what's really nice about that is because these are the exact same form of equations, we used Mohr's circle for all the plane stress situation, and we're going to be able to do a similar graphical display of Mohr's circle for plane strain, since they have the same mathematical form. So as a recap, here's plane stress Mohr's circle that we used previously. Remember that the angle on Mohr's circle was 2 times the angle in the stress block. We have completely analogous equations for plane strain Mohr's circle. And so this is a nice recap. We'll come back in the next couple of modules and we'll actually do plane strain equations using plane strain problems using Mohr's circle. So I'll see you then.